Sanibona. Buyile indoda kaMageba. Sizoqhubeka from ma-derivation ethu from grade 12. I hope you did watch our first principle, which is another way, which is the longer way of deriving. Remember, sithe ukuderive, it's finding the gradient of the tangent in a certain point. That's what we call derivative, gradient of the function. Hope you do remember that one. So now we will continue with our derivation, but now we will do the shorter way of derivation, where we use the rule we call power rule. But before we go there are some notions that I want to talk about when we are deriving. When I'm saying the notion, or not notion, the notation, sorry, notation, iy'ndlela ababeka ngazo, when we derive. Remember, sometimes bazokunikeza u-f at x, then bese bathi deriver. We already did this one using our first principle. We're just saying f prime into x. Once we derive, it's f prime into x. And then sometimes we're going to have y with respect to x. It's y with respect to s, it's where we have probably y is equal to say x squared plus 1. Then when we have y, must it y respect into x, like y equal to whatever the thing that we have on the another side, x. So how do we derive this? We do say dy over ubani dx. We derive y in respect of x. So I hope you see the two different. Between this we take f prime x, but this one we are saying dy, meaning we're deriving y into respect of x. These are a notation that we use depending on what we are given. Sometimes it's going to be y is equal to whatever, and then here f at x equal to whatever. Once we derive, if they gave you f at x or g at x or h at x, it's just going to be h prime x, then you write your derivative. But if they gave you y equal to whatever that they gave you, it's dy over dx. Once we derive, I hope you understand that one. And then let's continue. And then we have dx. Then inside here, they write whatever expression that they're going to write. I'm just going to write expression here. Then they're going to say, it's going to be like this. When we are deriving this one, it's not the same as this one. The f at x is going to be f at x equal to, but this one, it's dx, then they put an expression inside. So when we are deriving this, after deriving here, you're not going to put this. Let's just make an example by this one. You're just going to say dx okay, I'm just going to do examples so that we're going to have more clarity on how are we going to derive this. But when we're deriving this, it's just going to be, you're not going to write anything when you are writing an answer here. But let me just do an example. First thing, before we do an example, let me tell you how do we derive using the power rule. What is the power rule saying in terms of deriving? We're gonna have OA into XN. The power rule. Why I'm saying the power rule? Because we have this n which is called power, like exponent, bani power what, bani power what, this n. Then how are we deriving this? When we are deriving this, we're gonna take our exponent, which is this exponent, we're gonna times it with our coefficient. So it's gonna be exponent, this exponent or this power n, we times it with our coefficient. So it's gonna be n times a times money times n. If you understand that one. And then bring back our variable there, which is our expression, which is x. And therefore, we are taking this n now, we are minusing it by bani by 1. We are saying n minus 1. Guys, remember, we are saying n times the coefficient, which is just a times n. Mawuqeda la, the exponent yakho lela, or this power, we minus it with 1. So we're saying n minus 1. I hope you understand. I hope we do understand. But let's just do some examples. We're going to have dx into 2x cubed. Gonna have it like this. We derive this one. Remember, when we are deriving this one, we don't write any expression after deriving it. We don't show anything that we've already derived, like the first one, which is a prime one, and the other one where y is equal to, we do dy over dx. Here, we just say, use our power rule, which is this 3 times this 2, which is going to be 2 times 3, and then x, bring back our x variable, and then we're saying 3, this 3 minus 1. What is 2 times 3? 6. X, what is 3 minus 1? It's 2. I hope you understand. Start the exponent here too, say times and a coefficient, which is 2 times 3. Mawuqeda, uthatha that exponent, we are minusing it by 1. Then we simplify it, we get it like this. Let's do another example. Where is it? F at x equal to 3x squared. So now here, we are not just gonna leave an equal sign like this. Because if we derive, we have to say, because now this is no longer equal to local basic derive is no longer equal to f at x. So we need to show that f prime of x, meaning now since we are already deriving, right now. So this f prime x is very important. So now how do we derive? We are saying this 2 times the coefficient here 2 is just going to be 2 times 3. Then we bring back our x. Then after lapo, we are saying these 2, so minus ngobani, we minus it by 1. Derive, that's the power rule. Ishonjani power rule, guys. And then what is 2 times 3? We have 6. Then x, what is 2 minus 1, it's 1. You don't have to write 1 here, but if you want to, you can write 1. You don't have to write it. And then let's continue. Let's find another example. Of y equal to x into 4. Then we have y is equal to x into 4. Now we can derive this one. Remember, another notation of deriving this with y into respect to x. Then when we are deriving, we are saying dy over dx. So derive y in respect of x. So equal to, now we're going to say this 4, now we are deriving this 4 times the coefficient which is here. As you see, there is no number here, but now there's always a number here, which is 1 if there is no number. There is 1 if there is no number. But if beku 0, at the base of fire, they were going to put 0. But now, if there is no number, there is a number, which is 1. The number there, you must always know 1 is here. Now, you must know which 1 corner up. Make sure you don't forget that. So it's going to be 1 times money of 4 into x. And then 4, this, we are minusing this 4 by 1. Equal to, and then what is 1 times 4? It's just going to be 4x. Then what is 4 minus 1? 3. Hope you remember that one. I hope you do remember that one. Let's continue. We have dx into 5x let's derive. If we are deriving, remember the dx, or if you are deriving dx, you don't have to write this notation like this one, or this notation of f at x like f prime x. Most we derive in dx, you don't have to do it like that. So if we're deriving this, now remember, exponent here, there is an exponent. There is no number there, but there is an exponent, which is 1. We don't assume ukuthi 0 because uma ku-0, u-0 bazomfaka. It's not the same. U-0 bazomfaka. But now, if there is no number, there is 1 there. Angeke bamfaka ku-1. But if beku-0, ade bezomfaka. So we do have 1 here. So we're taking this one, we are timesing by this 5. So it's going to be 5 times money 1. And then x. Remember, it's 1 minus 1. The exponent in the corner, which is 1. And then we're going to minus it by 1. Then what is 5 times 1? It's just 5. And then x. What is 1 minus 1? 1 minus 1 was 0, guys. Now, you don't, value 0. Because now it's not the same when we have x emeganji. This x does has an exponent, which is 1. So the x law on the exponent of 1, mabengampalanga lutho uno 1. But if uno 0 here, which is 1 minus 1, uyamfaka u-0, guys. Please, ungamshiyi u-x engana exponent kanje. Because mawumshiye engana exponent kanje, meaning the exponent of that variable ubani 1. But if it's 1 minus 1, uyamfaka bani u-0. So our rules of exponent here, anything raised by 0, it's 1. So it's going to be 5 times 1, which is our answer here to money of 5. I hope you understand. I really hope so. I really, 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 really hope so. Let me just do the another one. We're gonna have y is equal to 12. Y is equal to 12. Now we're gonna derive this one. You don't have any variable here. You don't have x. You don't have anything. It's just y is equal to 12. Now, guys, you must know this. You must not forget this. It's always like this. When you are deriving a constant, a number, just a number, dy because over dx, derivative of a constant, it's always money 0. A derivative of a constant, it's always 0. The derivative of a constant, it's always 0. Make sure you don't forget that one, guys. Amamark amahala lawo. The derivative of a constant, it's always 0. And sometimes bazothi y is equal to pi squared plus pi. Guys, 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 dy dx. Pi is just a number. It's just 3 plus 1, 4, pi is just a number. Don't get confused. Pi is just a number. A derivative of just pi ubani 0. Don't get confused. Bangan confused, guys, please. Bangan trick. And then one, let me just do this one. G of x, which is 3 over 5 x squared. That's 5 here, it's not squared. Guys, there's something that is very important that I need to explain to you. Where x is equal to 5 over 5, x over 5 we are fine, guys. Let me just write 1 here. Because there's always 1 here. This thing is the same as 1 over 5 x. Yambo x bambhale kupla. Bambhale exactly kwi-numerator yakho. But here, x bazombhala kuphi? Esidini, just like this. This thing is the same as this. But this is not the same as this. I hope you see that. It's not the same. But these two things are the same. Bazokuconfuse abamthathu x bambeke la phezulu kwi-numerator. When I don't get confused. Guys, these things are the same. Don't get confused. So let's come back to our example here. So asibeke kahle ngendlela let we know. So it's gonna be 3 over 5. Uthathe nje u-x wakho umbeke la esayidini. Ungambeki kwi-denominator, guys, please. Ungambeki kwi-denominator. So it's gonna be just 5 la. And then we apply our rule, which is our power rule. So it's this 3 over 5 times bani 5, which is this coefficient here too. So times with our exponent, and then see what x into 5 minus bani 1 Hope you see that one. And then after lapho, 3 over 5 times 5. This 5 cancels this 5. Sala nobani, sala na 3. And then we have 5 minus 1. What is 5 minus 1? It's 4. So we're going to have 4 here. I hope you understand. I hope you do understand. Now, I'm just going to do another example, a little bit more of example. I'm just going to do more of example. But now, the example that I'm going to do right now, it's going to involve some knowledge. You need to know the knowledge of exponent from grade 10, grade 11. So I'm going to need that knowledge from you. You must remind yourself, guys, with that knowledge of the exponent. We are still deriving. We are still deriving. So just going to have f at x is equal to 1 over x squared. Now, guys, 1 over x squared. Angeke siderive if i-variable yethu, which is x, denominator. We can't derive. We must make sure we take our variable yephezulu kuphi, the numerator yethu, before we derive. We can't derive if it's like this. We can't derive. So let's derive. Must derive, we need to first take this thing, say numerator yethu. So this thing is still gonna be f at x. So sisazombuyisa f at x wethu because derive. Remember the rules of exponent. If uthatha i-base engaphansi uyisa ngaphezulu, the exponent of that base changes the sign. Iba ubani? Iba negative. So we're going to just say x ayingaphezulu, which is going to be negative 2. U1 lo, guys, ukhona lo. Let me just put it. It's there. I hope you understand that one. I hope you do understand it. Now we can derive. Now, masses derive, we are saying f prime x. Sesiyamfaka ku-f prime x because lento esisesoyenza manje is no longer going to be equal to bani, to f at x. So we need to put f prime of x because sizo-derive right now. It's no longer the same as f at x. So masses derive, we are using our rules of power rule. Sorry, guys, we're going to use the power rule. We are deriving. So it's in the power rule. It's saying 1 times bani 1 this exponent a2 times this coefficient a2, so it's just going to be negative 2, and then sibuyise x wethu, and then minus 2 exponent a2 siminasa ngobani? 1. We always minus by 1. Whatever case the exponent is either positive or negative, we always minus with 1. Simplify. 1 times negative 2 is just going to be negative 2 into x, then negative 3, negative 2, negative 1. We're going to get our answer as negative 3. Now, guys, very important. We don't leave our answer in a negative exponent. Awushiyi answer yakho in the negative exponent. Awushiyi answer in the negative exponent. So sizokwenza kanjani? Remember, our exponent was positive here. Then samthatha lo samusa ngaphezulu, i-numerator yethu uyashintsha sign yaba negative. Now, into soyenza, sombuyisela la beqhamuka khona ngaphansi. Masimbuyisela ngaphansi, i-sign izoshintsha again, and it's become positive. U2, guys, we just leave 2 as it is. This 2 is just the coefficient, has nothing to do with whatever negative exponent of this base. I hope you understand that one. So we're just going to leave our 2 here, negative 2 all over x into 3. Then just derive it. This is our derivative. I hope you understand. Hope you understand, guys. Let's continue. We have f at x of 3 all over x4. Hope you see it. Let's derive. So it's not derive now. No, we can't derive. Now, for now, we can't because our variable of x will be denominator. So we need to take our variable of x, the exponent yakhona, siyise phezulu kwi-numerator. Siyambuyisa u-f at x wethu because asika derive. F of x 3 coefficient x numerator masimusa numerator yaphezulu change sign negative 4 the exponent. Siyabona ngithi? I hope you do understand, guys, because now we're going to derive. If passes deriver, it's no longer f at x, it's going to be f prime of x. So f prime of x. F prime of x. Then now let's derive. It's a rule yethu, it's a coefficient times the exponent that we have here. So it's going to be 3 times bani negative 4. 3 times negative 4, and then x and negative 4 minus 1. I hope you see that one. And then 3 times negative 4, Bani, it's negative 12. Then what is negative 4? Negative 1, it's negative 5. Again, we don't leave our answer in the negative exponent. We don't leave our answer in the negative exponent. Then senza njani-ke? Remember, sithathe lo samusa ngaphezulu, i-numerator yethu washintsha isign yaba ubani? Yaba u-negative 4. Mbuyisela la qhamuka khona-ke, sign izoshintsha ibe njani? Ibe positive. So it's just going to leave this negative 12 here. Remember, coefficient has nothing to do with this base and this exponent. So we're going to just say x, then into positive 5. I hope we are still on the same page. Let's do another example.